Unit 10, Lesson 2. As you can see, the title is Describing Number Patterns. So we're going to talk about patterns, and this is one of the most important lessons in algebra, and we'll see how we can describe number patterns. To describe and extend a number pattern like 2, 5, 8, 11, we can use three methods. The first method, the table; the second, the graph; the third, algebra. In this lesson, we're going to mention the table, and you will see that it's going to work for small numbers. Graph, it's not a perfect strategy. And algebra, the last one, is the best one. That's why we included in the algebra strand of math. So the question is what? I have a pattern 2, 5, 8, 11, and the question is how can we find the value of the 10th term? So this is the question. The 10th term. How we can find the value? First of all, what the meaning of 10th term? If you look to this pattern, 2, it's on the first term. 5 in the second term. 8 in the third term. 11 in the fourth term. So each one has a position. Now we are looking for the 10th term, so it's very far. That's why we have to find a way. So let's talk about the first method, which is a table. How we can find 2, 5, 8, 11. This is a value of the term. So as you can see this table, it's saying term number and term value. We have the value already. We have 2, 5, 8, 11. So I'm going to write this value 2, 5, 8, and 11. And let's say I'm going to use another color for the term number. Term number means the position, as we saw here, the position with the first, the second, the third, the fourth. So it's easy. So I'm saying when the term number was 1, the first term, it was 2. For the second term, the value was 5. For the third term, the value was 8. For the fourth term, the value is 11. Now the question, how can I predict the 10th term? So in this case, I have to check something very important here. To check this value, it's going from 2 to 5. How can I go from 2 to 5? As you can see, I'm adding 3. How can I go from 5 to 8? As you can see again, I am adding 3. From 8 to 11, again, I am adding 3. That means I can continue to add 3 till the end to get all my numbers. So that means I can continue term 5, term 6, term 7, term 8, till I reach term number 10. So in this case, I have to calculate. If I have 11 for term 5, I'm gonna include, or I'm gonna add 3, so it's gonna be 14. So this is the way. If I need to know the number, all I have to do is increase from the previous number 3 extra. So now for 6, it's gonna be 17. For 7, it's gonna be 20. For 8, it's gonna be 23. For 9, it's gonna be 26. And for 10, it's gonna be 29. So in this case, the 10th term is 29. As you can see, this method that we call it a table, it's reasonable if the term number was small, the 10th term. But if the teacher asked me for the 100th term number 100, do I have a time in the quiz to go add 3 till I reach number 100? For sure no. So we need to find something more realistic, something that can help me with large number. Okay, so the table, as you can see, it's perfect for small number, and this is what we were using for grade 5 and 6. Now we are in grade 8, we have to find another method. Okay, let's check the second method, the graph. The graph method, as you can see in this drawing, you can see that I am using a graph. This graph, it's between the term number and the term value. Again, with the same way, we are introducing only term number and term value in anything. So let's go back to our table. When the term number was 1, the term value was 2. Easy. So I can come with the blue color and I can see, okay, when I had the term number 1, I had a term value of 2. So if this 5, this is 2.5, that means little bit here under, I can put a small dot when it was 1. Excellent. Next, when it was 2, the term number, the term value was 5. Okay, this is easy. When the term number was 2, the term value was 5. Good. Excellent. What about the third? When it was term number 3, the term value 8. So when I have the term number 3, I have to reach 8. This is between, this is maybe 7.5, that means 8 almost here. And I continue. When term number is 4, the term value it's 11. Okay, 4, 11. 11, it's almost here. When the term number is 5, term value is 14. Term value is 14, something like here, approximately. So now, how can I find the term value of term number 10? All I have to do is use this information that I have it and draw a line. So all I have to do, I'm gonna come with a line and I'm say, okay, this black line, it's gonna draw for me what do I need. So I can go from here and extend line that it pass through all this point, and even I can extend it to the maximum that I can do to find any value that I need. So let's check for the question. Let's check for the question. The question was saying what? What is the term value for term number 10? So I'm gonna search for the blue and I'm gonna say 10. Let's go up, 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 up. It can reach to this point. This point for me, it could be 28, it could be 30. It could be 28 or it could be 29. 30, it's up. So 28 or 29. So I can say 28 or 29. And because I'm not sure, that's why we are saying that if my graphic is not perfect, I can get an answer that is not perfect 100%. So as you can see, the first strategy was a table. We said it's good for small numbers, but if I'm looking for term number 100, gonna be headache for me. The second one, if my graph is not perfect, I can get something flu. I'm not sure, 28 or 29. And from our calculation, you know, it's 29. This is the right answer. So again, the second method is not a good strategy. So the third one, we call it the algebra method, and this is the perfect one. So let's see how we can use the algebraic way. The algebraic way is saying that all we need is to find or to write an algebraic expression. As soon as we find the algebraic expression, I can find the value of any term number. Even if the teacher asks me for term number 200, I can find the value. So how we can do this one? I need your attention, please. This is the most important part of the lesson. To find the algebraic expression, there is two strategies. So I'm going to mention the first strategy first, and as you can see, I'm preparing a table to have the relation between the term number and the value. So exactly what we did before, we're gonna repeat it. So I'm gonna choose, let's say, the red or the blue for the term value, term number. So 1, 2, 3, 4. So as you know, the term number is the position, the first one, the second one, the third one, the fourth one. The term value, as you know it from here, we have 2, 5, 8, 11. So again, I'm going to repeat it. 2, 5, 8, and 11. Now, as we mentioned before, the relation between the 2 and the 5 and the 5 and the 8 and the 8 and the 11, they are the same. All we are doing that we are increasing by 3. I'm adding 3 to 2 to get 5. I'm adding the 3 to the 5 to get 8. I'm adding 3 to the 8 to get 11. As you can see, because we are moving by 3 or we are increasing by 3, that's why we are saying we're going to learn something new, that we can say that the algebraic expression is going to be 3n. What is n? Is a term number. Can you see the n here? Is a term number. Hopefully the 3n is going to give me the right answer. So let's check if 3n is working or not. For term number 1, n is 1. 3 times 1 equals 3, not 2. So we have to adjust this. How to go from 3 to 2? I have to remove 1. I hope the 3 minus 1, it's not going to work only for term number 1 only. It's going to work for 2 and 3 and 4. So let's check it. So when n equal 1 for the first position, the algebraic expression is going to be 3 times 1 minus 1. 3 times 1, 3. 3 minus 1, 2. Wow, we have the same value, 2 and 2. Excellent. Let's go to the second one. When the n equal 2 for term number 2, I will replace n by 2. So 3 times 2, and again I keep the minus 1. Let's do it together. 3 times 2, 6. 6 minus 1 equal 5. If the value of term number 2 is 5, yes. This makes us happy that the 3n minus 1 is working. Let's continue to check for 3. 3, n now is 3 minus 1. 3 times 3, 9. 9 minus 1 equal 8. Is 8 is a value of term number 3? Yes, it's 8. Let's do the fourth one, and if it's gonna work for the 4, we're gonna stop at this level and we're gonna confirm that the algebraic expression 3n minus 1 is the correct one. So 3 times 4 minus 1. 3 times 4, 12. 12 minus 1, 11. Is 11 is a value of term number 4? Yes. That means 3n minus 1 is my algebraic expression to find the value of any term. So at the beginning of the lesson, we asked to find the value of term number 10. Let's check. We have already the answer. We have the answer from the table. If you remember, 10, its value is 29. Hopefully it's gonna work here. When n equal 10, so 3 times 10 minus 1. 3 times 10, 30. 30 minus 1 equal 29. Yes, it's the same. And even if the teacher asks us to find the term number 100, no problem. I can say 3 times 100 minus 1. That means 300 minus 1 equal 299, and this is going to be the term value of term number 100. So that's why I'm saying this is the best way or strategy to use is the algebraic expression. It's better than the first one with the table. The table, to reach term number 100, we have to do calculation like crazy, but for this one, only using the algebraic expression we can get the value. This is strategy number 1. There is another strategy. to find an algebraic expression. Let's check it, and after that I will show you that even if I get another algebraic expression, both are leading to the same answer. So let's check how we can get it. Again, I'm going to return to the main issue is term number n and value. Again, first term, second term, third term, fourth term. Again, the value is 2, 5, 8, and 11. And again, the difference between 2 and 5 that I'm adding 3, 5 to 8 I am adding 3, and 8 to 11 I'm adding 3. Again, the same thing. Now, instead of using the algebraic saying 3n and fix it to -1, there is another strategy. Let's start from down. Let's check with the green color for n equal 4 for the fourth term. We're going to say what? When n equal 4, how many or how do I get 11? When n equal 4, I can say I am starting from 2. So 2 plus I am adding number 3 times. So 3, I'm adding that 3 times. And actually this is correct. 3 times 3 it's 9. 9 plus 2 equal 11. That's why I have 11. Okay, let's continue and see what we can get more. As you can see that I'm using always from the bottom and I'm going up. When n equals 3, how can I get the value 8? Let's do it. We start always from 2. Okay. How many times did you add 3 to get 8? 1 and 2. 2 times only. 2 times only to add the 3. 2 times 3 equals 6. 6 plus 2 equals 8. Nice. I got the 8. When n equal 2, the second position, how did I get 5? Let's see. We start from 2. We start from 2. How many times did I add 3 to get 5? Only one time. So only one time I added 3. 3 times 1 equals 3. 3 plus 2 equals 5. Nice. Let's check even when the term number equal 1. Usually when the term number equal 1, I used 2, and if you see up, I didn't add 3. That means 0 times I added 3. 3 times 0, 3 as 0. 0 plus 2 equal 2. Wow, so that means in my 4 calculation here, I have to get the algebraic expression. Let's see. I see the 2 is standard. I see the bracket 3, it's standard. The only thing that it changed 3, 2, 1, and 0. Now we need to figure how can I get something close to the term number. I want that you to get your attention. Can you see here? When the term number is 4, I am using number 3. When the term number is 3, I am using 2. When the term number 2, I am using 1. When the term number 1, I am using 0. What is the relation between this number and n? As you can see, it's 1 minus. So n minus 1, I have to put it here. And you will see that this will be my algebraic expression. Someone will tell me, wow, this algebraic expression 2 plus n minus 1 between bracket times 3 is totally different than the first one, 3n minus 1. Why they are different? I will answer this question in 1 minute. Let's check this one. If this algebraic expression will give me the right answer for n equal 10, because we know that n equal 10, we know the value is 29, so let's check it. So 2 plus 10 minus 1 times 3. 10 minus 1, 9. 9 times 3, 27. 27 plus 2, 29. Wow! It gave me the right answer. Can I test it with when n equal 100? We know it's 299. Let's check it. N equal 100. Let's check it. That means 2 plus 100 minus 1 times 3. 100 minus 1 equal what? 99. 99 times 3. 99 times 3. 3 times 9, 27. 2, 3, 9, 9, 27, and 2, 29. I have to take this number and I have to add 2. That means 299 again. So that means this algebraic expression is working fine. Now I need to answer the question that I mentioned before. How we can get two different algebraic expression and they lead to the same answer. So let's write these two. I'm going to choose, let's say, the blue color. And let's take the first algebraic expression. The first algebraic expression was 3n minus 1. 3n minus 1. And the second one was 2 plus n minus 1 times 3. How can I see that these two different algebraic expressions, they give me the same answer? Actually, they are not different. I will prove that right away. If I continue this one, 2 plus, let's use the distributive property that we got it previously when we have to multiply algebraic expression together. So 3 and n minus 1. So 3 times n, 3n. 3 times 1, negative 3, because it's negative 1. Okay, so let's finalize this. 3n stays 3n. I have negative 3 and positive 2. That means negative 1. Wow! They are the same. So we proved that both they have the same value. That means they can lead to the same answer. Even if the shape is different, the first one 3n minus 1, but the second one is 2 plus open bracket n minus 1 times 3. That means the two strategies are correct. Which one you want to choose to do your homework or to do your quiz, it's your choice. Whatever you feel comfortable with, you can use it. Some students, they prefer the first one, it's easy. Some students, they say no, the second one, it's more easy. So whatever you like, you can use. The most important part that you know that we have three ways: a table, a graph, and algebra. We said the table is good only for small numbers, but if I'm gonna go for term position number 100 or more, it's gonna be very hard for me. The graph, it's not perfect if my drawing is not perfect. So the safest way is the algebra. This is the one that for grade 8 really, because you will see in the future they gonna ask you for term number 200, term number 1000, big numbers. So the algebra is the best way, and in the algebra we saw that you have to find the algebraic expression and there is two strategy. I hope you understand this lesson. It's a very important lesson, and we're gonna continue next time, unit 10, lesson 3. Thank you.